Hello again. I'm Earl Silverman, Editor-in-Chief of the Journal of Rheumatology, and this is now my third month of interviewing authors of a paper I picked from my editor's picks. For the month of March 2021, the article I picked is entitled Propensity Score Methods in Rare Disease, a demonstration using our observational data in systemic lupus erythematosus, and is by Dr. Ibrahim Almaghlouth when he and his colleagues from when he was at the University of Toronto, Ontario, Canada, and Ibrahim is now at King Saud University in Saudi Arabia. The paper is now available for viewing at the journal's website at jroom.org. Now I'm pleased to interview Dr. Almaghlouth. Ibrahim, I want to thank you for taking the time to speak with me and to our listeners about your very interesting, important article demonstrating how we can use propensity scoring to better understand rheumatic diseases and how this methodology can be used to decrease potential bias from confounding when examining observational studies. So we'll begin, and I want to thank you also for joining us.
Thank you so much.
My pleasure. Could you briefly describe the principles that are used in propensity scoring?
Perfect. Thank you so much again for having me. It's always great to see you, Dr. Silverman. So essentially, I think we always want to go a step back as a clinical researcher and ask the question of why do we need to use all of these methods? The primary problem when we have an observational studies, which are very important studies to understand rare diseases, is that sometimes when you look at the association between an exposure and an outcome, we get into the problem of confounding, where there is a factor associated with the exposure and the outcome and not in the causal pathway. Now, this problem can be adjusted methodologically in several different methods. However, in 1980s, Rubin introduced the concept of propensity score, which is a very interesting idea in which if we can calculate the probability of getting the exposure of interest or the treatment of interest and give it a number, and we ensure that this number is balanced in both exposure and control group, so both study group, then we will have a way to reduce the confounding effect in the observational studies. Now, this propensity score essentially can be calculated using conditional logistic regression, in which we look at all the variables that can lead or can increase the risk or the prediction of having an exposure of interest. So for example, if we are giving a treatment and we want to compare the treatment effect in exposure group versus no treatment effect on the control group, all the factors that led to the assignment of treatment in the exposure group, we include it in a logistic regression model, and then we predict a score for all the study cohort, including exposure and control. After that, we can use this score to balance both groups. Now, there are 4 classical methods in which this score can be used. And they are as the following. The first one is matching, and it's very simple, straightforward. We try to match both groups in terms of their propensity score by different methods of proximity, and then we ensure that the score did its job by balancing both groups in all variables except the exposure, which is the thing that we want to examine on the outcome of interest. So that's essentially the matching, and we can talk about it further. The second one is essentially stratification, in which we stratify all study groups based on their propensity score into smaller groups that are similar in the propensity score, and then we calculate the effect of exposure on the outcome on all these small groups, and then we pull the results, the measure of estimate at the end. And the third one is essentially adjustment, which is essentially a reflection of what we usually commonly use in observational study, in which we use the score as a variable in regression model, and then we adjust for it in the regression model. And the last one is the inverse probability treatment weighted method, in which we give a larger weight for a control group who has lower propensity score, and lower weight on the exposure group in which they have higher score. And in that way, we ensure that the balance is there. We restore the balance between the exposure and the outcome, creating what we call pseudo-randomization. But we can talk about it further. So that's in a nutshell the brief about the methods.
Excellent. So now maybe we can go a little more depth into some of them. And we'll start with matching, which is actually, to me, the easiest one, because that we're used to. Go ahead.
Yes, absolutely. So matching is a very, very straightforward method. In this method, we obviously, when we calculate the propensity score, we assign a score. We assign a score for each individual in the whole cohort, including the exposure and the control group. Now, after that, we try to match people not based on all variables, but instead we match them based on their propensity score. So with similar propensity score or very close propensity score from the exposure and control, we match them together. And we usually do that by defining something called proximity, using proximity method. And we define the proximity based on something called caliber width. And essentially, the way we calculate this, there are different cutoff points. The smaller the cutoff point of the width, the closer they are and more similar they are. And we usually use something like 0.2. And it is simply, it's the standard, the caliber width is calculated based on the standard error of the logit of propensity score. Now, once we do that, we end up with matched groups in which they are very similar. They are similar in terms of their propensity score, and they are only different in terms of the exposure of interest. So, for example, in our study illustrated that we used to illustrate the concept, we tried to look at the effect of low immunoglobulin in patients with lupus compared to those who do not develop such abnormality, and the outcome of interest with infection. So the first thing we did is we matched the propensity score of those with low immunoglobulin and those who never experienced low immunoglobulin. Now, that's step number one. The second step, which is commonly required, is to ensure that the propensity score did its job by balancing both groups in all variables except the exposure of interest. In our example, would be low immunoglobulin. And you do that by different methods. One of them is standardized difference or the statistical equation. So essentially, you look at the statistic between both groups, or you can do the standardized difference, which is simply might be more robust way to look at the difference between groups. And once you ensure that both groups are similar, which is very important step in anyone who's reading propensity score, reading an article using propensity score matching, then you would say, now it's time to look at the measure of effect, or looking at the association between your exposure and your outcome. So that's essentially matching. The caveat with matching, and I think this is probably the next question is, why do we use matching and why not the others? Matching is very simple, straightforward, as you clearly mentioned. We are used to it. The second thing, matching is also very robust in ensuring similarity between both groups. So that's a very important point. However, matching tend to reduce the number of reduce the sample size, which may affect the power of the study. simply because you wouldn't be able to match everyone. And one of the caveat or one of the criticism about matching is that, well, you did not study everyone, you eliminated some people, and maybe the effect of your exposure on these people is different than the effect of the matched group. So these are some of the pros and cons regarding matching.
That's good. Yeah, it did strike me that you talked about this width of how to match, and obviously the narrower, the harder the match, the more broad, the less good your matching. So thank you. That makes sense. So I guess you said an alternative, if that doesn't work, would be to go to stratification.
Yes. Now, stratification is also a very interesting and unique method. The method essentially is simply based on stratifying all your cohort, both exposure and your control group, based on their propensity score. So higher propensity score group subgroups will be, you will create subgroup or stratum. In each stratum, you'll have similar, more or less, propensity score. There are different ways to create such stratum. Some of that is the quantile, 5 quantiles, for example, and then within each stratum, you will have an exposure, a subclass of your exposure and a subclass of your control who are similar in their propensity score. When you do such thing, you reduce the difference in terms of all the variables that may affect your the relationship between your exposure and your outcome, and you can essentially estimate your effect on each stratum, and then you pull them together. There are different ways to do that, and each way has its own advantage. In general, the original question in the original papers in which stratification was used, it was shown that stratification can reduce or eliminate about 90% of the bias or confounding bias that is related to imbalance between both study groups. However, there are several criticisms about stratification. First of all, you may not have the power. When you do so, you reduce the power automatically within each subclass, and you also may end up with some subclasses that are not very well balanced. However, there are more advanced methods. So in the advanced method and propensity score used, Dr. Austin, who's well-known, affiliated with the University of Toronto, been producing a lot on propensity score lately. There are several ways that account for such problems. And some of the advances in propensity score has been in the stratification method. So that's in a nutshell how we stratify. There are several papers that use stratification in field of rheumatology, but it's not as common as other methods.
Very good, thank you. Now we'll move to adjustment. We all hear about adjustment, but in my heart of hearts, I wonder how it works, especially, what came to my mind, somebody was looking at COVID-19, of course, because it's everywhere now. And they said they adjusted for ethnicity. But when I read the paper, they were very unbalanced in Blacks. And we know that there's a much higher rate of death. So, but when you don't know the rate, how do you adjust? My real question comes down to, if you don't know what the effect of something is. I understand if I have double amount of people in one group, I could adjust somehow. But if I don't know how that, let's say, that ethnicity actually alters the outcome, how do I adjust? So that's really what I'm getting at. And how does propensity scoring help you with that? Really is the question. That's what we're dealing with.
That's a wonderful point that you just raised. So see, the question always from researchers who tend to avoid propensity score or use the usual old-fashioned regression model is, well, for example, why do we need to go to propensity score, for example? And of course, there's no one score that solves all problems on Earth. However, you are absolutely correct that some of the remaining residual bias that can be related to the effect of some of the variables that have been significantly different between study groups, exposure and control, is commonly found, or we tend to see it more often with regression model. There was a very nice study that was done by Dr. Austin. Again, he's been producing a lot in this field, where they compared classical regression model in a simulation study with different methods of propensity score. And what they found is very unique, and they use simulated data. So with simulated data, you essentially know all the numbers and all the confounders, and it's kind of controlled group environment. In his study, what they found is, well, if some of the propensity score methods are robust to bias in several aspects, and if they are used sometimes, they are more conservative in their estimates. So they might be, if there is some bias with propensity score, tend to be skewed toward null. In another way, it's a conservative way to look at estimate of effect between an exposure and outcome. Well, in comparison to regression model can perform well only if you account for all variables, and it's a perfect model where you know all the variables and all effect of different variables. And that goes to your point, because then if you don't do so, there will be a tendency of regression model to be skewed toward biased estimates. And especially when you don't have a measurement, or when you cannot estimate the effect of one variable. When we use propensity score and adjustment, it's really a very straightforward method where you use the propensity score as a score, and obviously you put in the regression model in addition to your exposure of interest. So for example, in our study, it was hypogammaglobulinemia, and then you look at the outcome of interest, which is, in our case, was clinically relevant bacterial infection. Now, what does that do? Essentially, you account for the impact of all variables that you use to estimate your propensity score, which we believe might be the reason of confounding effect in our study. These are measured variables. However, obviously adjustment has been criticized, and it's one of the least favorite method in propensity score for the reason that we just mentioned, and also for another reason, which is it adjusts on the measure of it accounts for it does its job by adjusting for the estimate between the exposure and outcome. However, the other methods, if you saw with if you saw earlier, propensity score match or inverse probability treatment weighted method, they create some sort of pseudo randomization. They work on balancing the study groups rather than the estimate of the exposure and outcome. And that's one of the beauty of the propensity score, creating what sounds like pseudo randomization.
Thank you. Excellent. Now I understand it better. Much appreciated.
Well, you're such a humble person, Dr. Silverman. We know that you taught me most of the stuff, but thanks for you.
Not stats, I'm telling you. Oh, you're too nice. Last method is inverse probability weighting. And if you can just explain to our audience really what that means.
Of course. So see, we just mentioned earlier that propensity score is a balancing score. We want to ensure that your both study groups, your exposure and your control, or your treatment group and a control group, they are similar in everything except your treatment or your intervention or exposure of interest. Now, one way is to match, another way is to stratify. The third way is, what if we actually give higher weight for individuals in the study with lower propensity score and lower weight for the individuals in the study with higher propensity score? And that's the idea with inverse probability weighted. So what we do, we for the exposure group, for the study, for the intervention group or the exposure group, we give a weight of 1 over the propensity score. And for this control group, we give 1 over 1 minus the propensity score. Now, what does that mean? Is that when we measure the effect of the exposure on the outcome, we actually adjust this measure of effect based on the weight we give for the individual. Now, why? What is the advantage of this? So that's the real question. So the advantage is, 1, we use all the study sample, so that maintain power. And this is very important in studies, observation studies, especially in rheumatic disease where we have a small sample or small populations. And so that's number 1. 2, when we do so, we avoid the criticism that's been raised on propensity score matching, in which some individuals will be eliminated of the study because they did not match in your study design. And so you include everyone in your measure of estimate. Now, the caveat or the catch with this study, with this method, is that sometimes when we have high, like really extreme weight related to either very high or very low propensity score, since we are weighting on the inverse of the propensity score, some weights will be extreme, and this may affect the results and stability of the weighting. So what we do in that situation, we either truncate the weight, so we say we'll just will apply certain type of weight, or we multiply in a stabilizing factor. In another way, we try to ensure that the weights are stable, even if there are extreme weight. And when we do so, we essentially have a better, obviously, results, and we account for such extreme weight. Now, another advantage of inverse probability treatment weighted method is that there is something that we commonly use, we tend to forget about when we do our study designs, especially observational study. With most of the method that we use classically, for example, regression model, we estimate the average, something called average treatment on treated, conditional treatment effect, i.e. the effect of a treatment conditioned on all other variables. And that only allow you to have certain measurements, which is essentially does not reflect what we usually do in clinical trials. In clinical trials, we calculate something called marginal treatment effect. So what is the treatment effect on a large group of people compared to another large group of people? But when we do regression model, we tend not to do that. Instead we do something conditional treatment effect. With inverse probability weighted, we can calculate both average treatment on treated or average treatment effect. So in another way, it gives you more flexibility to have different measure of estimates, and it does. Actually, it's one of the best methods to create what we called earlier pseudo-randomization, where if in a hypothetical world in which your exposure can be randomized to a study to a group A and group B, what would be your randomization? And that's essentially what inverse probability weighted treatment aim to do.
Thank you. Very excellent summary. I can understand, and I think that was great. Anything you'd like to add?
I think, thank you for giving me this opportunity. I think the most important part of this study that we try to highlight, and thanks to my obviously supervisors, particularly Dr. Sindhu Johnson, who've been my methodological supervisor, Dr. Urowitz and Dr. Gladman, and all the other colleagues who helped with this paper. The idea that we try to highlight is, as a researcher, we try to get as close to the truth as possible. So this is what we're trying to do. We try to look at, to do studies in which we make sure that we are as close to the truth as possible. And there is no single method that will essentially ensure that the results are 100% true. However, what we need to do is to try different methods, particularly applying more sensitivity analysis with different methods that account for some of the issues in small observational studies. And what this paper aimed to highlight is that one of the very useful methods to be applied in small observational studies, especially when we have lower event rates, small event rate, or a smaller sample size that is very robust to a confounding effect, is the propensity score. And I will conclude with one very nice paper that preceded this paper by Sindhu Johnson, who did a simulation study in which she tried to highlight that if you have a small study sample, let's say we had in her study, she used an example of scleroderma, and she had very small sample size, about 20 in each exposure and control group, or 40 in each of the group. If we randomize those people into exposure and control group, or treatment and control group, and look at the residual imbalance between group, randomization will result in larger imbalance compared to propensity score. So it is a very conservative approach, and I think it has not been utilized as much in observational studies. And I think there is really a growing role for such method, especially with the advancement in the application of propensity score. And I will refer to a latest paper by Austin in Statistics and Medicine in 2020, who highlights some of the very advanced application of propensity score.
Thank you. That was excellent. And I really want to thank you for taking the time to speak to me, even with the time change between Toronto and Riyadh. And to our viewers, please read the full article. We had an excellent explanation, but I think you'll learn even more from reading the full article entitled Propensity Score Methods in a Rare Disease, a demonstration using observational data in systemic lupus erythematosus by Dr. Almaghlouth and colleagues at jroom.org. And we love to hear your comments either on Twitter at jroom or by email at manuscripts@jroom.com. I want to thank you for joining us and hope that you will join me next time when I speak to the first author of one of my April picks. Bye for now and stay healthy. And again, we miss you in Toronto, Ibrahim, and thanks for speaking to me.
Thank you so much. I miss you too.